Hello there, it's Ingus from IGS Electronics, and today we're gonna follow up the last video where we looked at Allen Bradley Powerflex 4 family drive, and we in the last video looked at how things to be done remotely, set up locally, and we set the drive up to be ready to go. We went through a lot of parameters. And today we are going to continue, but we are going to run the drive from a remote connection. So for remote connection is, let me just zoom this in. We'll be using these load of digitals down there. As you can see down there, I already have a couple of cables wired in. That's for my own testing for the different system, but today we're going to be trying out some of the options that the drive is offering to use for. In most times, especially in industry, this drive is usually powered run externally by external relays. But today we're going to look like the simple ways of setting this drive up and running in a couple of options that Allen Bradley is offering, and we're going to be following this little digital wiring diagram that Allen Bradley has done. As you can see down there, is the main thing you see is already been set up what each digital input does. And as you can see, our source comes from 11, where 11 is that the drive supply power for the digital input. So to close any of the inputs is basically quite simple. Is once you change your mode to remote, if you take the signal from the 11 and connect to any of the digital inputs like 1, 2, 3, and 4, all they will change the state, and drive will do whatever's been assigned to that digital input. Like 1 is a stop, and 2 is a start forwards, and 3 is a direction and directional thing, reverse and forward, it can be swapped over. So and obviously the other digital inputs like 4, 5, and 6, they both can be programmed, and which if we have a bit of time, or maybe in the next video I'll see how it goes to see if we can put it in some three-speed connection, because this drive offers you can have the three preset frequencies which you can set to each digital input. As the digital input is activated, that set of frequency will be used for that time. So, but the first things first, today we're going to look at is we're going to show you how to change across from local to digital inputs, and then we're going to test out three options that the drive is offering, which is a 2-wire option, 3-wire option, and the one we already tested last time was in a keypad option. Also, there's another option which you can use via network, but which you're not going to do today, because that's just way above basic. And another thing I want to point out, which is very unusual for the drives, but Allen Bradley does say, as you can see, it says potentiometer is 1 to 10 kilowatts, but it does state very clearly 2 watts minimum. Most of the potentiometers are coming 1 watt. I don't know why Allen Bradley requires 2 watts, and then as I don't have a potentiometer with a 2 watts, we are not going to be using it. So, but the potentiometer is basically, you would use a 12, 13, and 14, which are down here. You would wire those, the potentiometer in there. The main in this video we're going to be using the front one down here, which we're not going to change, but will show you. I think I showed you in the last video how to change that as well. So bear in mind your potentiometer must be 2 watts minimum. So let me just zoom in and get ourselves ready for show you how to swap over again, which we've already seen last video, but we'll do it again this video, how to swap over. And the first thing we can connect up is 2-wire connection, which is very basic. Okay, to jump from front keypad to terminals, I already done it, so I'll show you again. It's a parameter 36. We enter it, and we're gonna do the first connection. We're gonna do the 2-wire connection, which is in a setup 2. So just save that one, and then once you've done that, escape, and you'll see the green light from the start is gone. So I'll just quickly show you. This is now we're gonna be working from these terminals in here, and I'll quickly show you how manufacturer would like you to connect the drive up when it comes down to main phasing. This is for the 3-phase one, but the same principle applies to single phase. So that's what they call the essential requirements for CE compliance. But obviously in the basic setups and things like that, so this sort of setup will be fine. Another thing is what a lot of the drive companies are suggesting we to do is use some sort of EMI filters or a harmonic suppressors. And if you've probably ever seen something like this into the machines, if you've ever seen the machines, things like that, they are called the harmonic suppressors. So it's like looks like a big transformer. It's not really a transformer. So all it does is sort of it doesn't completely remove the harmonics, and harmonics is a big subject you can discuss and watch online what it does. But to cut things short, when there's a huge harmonic distortion, a lot of bad things can happen in line because the sine wave is no longer perfect, and they start creating all sorts of different harmonics and currents. So and then you can really make a lot of bad things going on in your network. And if you're a public network and you're running something big, let's say 5 or 6 kilowatt drives, and you don't have this harmonic suppressor in there, it could cause a lot of trouble for your neighbors and all the things around it. So I'm not going to go too deep into this harmonic thing, so you can look online what it does. But if the drive goes, I would always go like that. Like once I start going for a 3 kilowatt drive, I would start looking at possibly installing a harmonic suppressor just to iron out these distortions that would possibly happen in your power lines, which you don't want to have too much. And plus as well, if you see harmonics are really bad, it means you're using too much power. So the power company has to substitute your losses and all sorts of things. It's just basically you want to make sure that sine wave is as smooth as you can get, and to do that. And drives, the VFD drives are the biggest causes of distortion when it comes down to harmonics and sine waves itself. So advisable to use it if you can. Obviously it's a hell of a lot of extra expenditure, but for small drives like homes and home drives like 2.2 kilowatts and things like that, you will get away with it more or less. But for the bigger guys who go into it to use big drives, I would strongly advise to use a harmonic suppressor, which is as I showed in the picture. And then if you look at the even when you in a page down here where Allen Bradley is writing as well, installation on public low voltage power networks may require additional organic harmonic mitigation. So they do advise it as well for you use that kind of system. But that's regarding that. This is something that I thought I myself point out there. So if you ever see one of those, you know what they do. So just quickly have a look at the wiring down there, as I already showed it last time. This is where your single phase goes in, line, neutral, and this is where your 3 phase is going to come out and goes directly to the motor. In my case, obviously it's different, which I showed in the last video as well. It goes through this little contactor, which is run by a buttons down there. So where my system is, my system is fairly protected when it comes down to e-stops and things like that. So I can just smash the e-stop and the power is gone from the motor. So first things we're going to try is this 2-wire connection, which is basically a small unit like that. It's very basic to get you going. I am running the drive from a relay down there, but as not everybody has that kind of system, we will just connect something like that. Very basic. Is e-stop. The reason I use e-stop is basically just to stop the drive very quickly rather than trying to push the button. And then it's just a latching switch down there. So we're just gonna turn things on and turn things off. That's about it. So let me wire this in, and I'll show you how it works. Okay, now that we have wired it in, so our little unit down here. Let me zoom in and show you how that is in there. So to understand these little points down there, it's a shame you can't see any numbers in there, but there'll be like 1, 2, 3, 4, 5, 6 and things like that. So in a wiring diagram, it's this very this is the basic diagram when it is on 2-wire system. This is what it would be wired as this one. So the number 1 is for the stop, which is linked out at the moment because that feature becomes live when you use the 3-wire system, which I can show in a minute. And then as I was the second one is for start forwards, and then third one's for direction, and then 4, 5, and 6 are can be preset to whatever you want to do. And after that is other bits in there, which comes down to 11, 12, 13, 14, 15, and 16, which is for analog inputs for frequency controls and things like that. So let me just remove this one. So to get you basically started, so if you see down there, this part down here, this number 11, which is down here, is basically your power point from the drive to activate inputs. And as we've spoken in other videos already, all the inputs that can be activated with a 20 volt signal externally or internally. Each drive comes with the internal power supply to be able to power input. So basically all you need to do is run 11 wire to your normally closed part of it, which already I spoke to normally closed, normally opens before. It goes through my normally closed, which is all the time closed, and it goes to normally open, which is my selector switch, which is going to latch the thing in and just go back to basically close the loop and closes off number 1. Number 2. And number 2 in our case is go forwards, and if you click it forwards, e-stop is on, drive just goes, and then I can still with this control my speeds if you want to. As you can see, my the acceleration times are really low, so it changes quite quickly. Also that can be adjusted in different types of settings. So again, very, very basic. All you're doing here is just close the loop between 11 and 2, and it goes. And once you do that, just the reason to stop the whole system, you can click the e-stop and it will stop it. It's basically breaks the loop. So when you release it, it will start going again. So it's sort of I don't like it that way, no, but this is the way you could operate this drive if you want to. So very simple, very easy to get this running. So as we've done that, let's go to 3-wire system. Okay, the wiring is done. So this time we are using a little station like that with the start stop button and directional button, and I'll quickly go run you through the wires. Before we do that, let's change. I already changed it, so I'll show you again. So we go for 36, enter, and we need to change that to 1. So 1 means 3-wire connection. A 3-wire connection allows you, when clicking the start button, the power will stay on, and by pressing the stop button, you will stop. Pretty much create your own DOL station. So when you click the start, it goes. At the moment we are in reverse mode, and we press the stop, it will just stop. So now I as well throw in like a small directional button. If you can see down there, when I switch directions, you can see the little light forward or reverse to tell you which way the drive is going to go. So just for the direction, if you ever need that. If you don't bother. If you just want to run the drive like this with a start and a stop, and you can still control your references from the front keypad, unless you really need the Yes, you really need to control the speed quite often, and then you want to keep the drive far away from your whatever the workstation you're working on or whatever system you're building on. Then yeah, by all means install a potentiometer, which is again quite fairly easy to do. Just make sure the potentiometer is from 1 to 10 kilo ohms and above 2 watts. Well, not above 2 or above when it comes down to power. So that's pretty much it when it comes down to 3-wire connection. I think this is very sustainable thing, and obviously I would advise again to install a proper emergency system so your system can be stopped properly with the e-stops. But again, this is just to demonstrate how that works, and I forgot to run through the wiring, how it does. But this time, as you can see, the little link that I had in here between 1 and 11 is gone, and it's been replaced with the stop button with the normally closed system down here. So now from 11, which is our source from the power, from 11 down here, it comes out and it comes to this stop. Let's just zoom in to the stop part of it. Then it goes through the stop, and it sends the signal to both of the normally open contacts down there. One is for start, one is for changing directions. Again, as these buttons been pressed or latched in, it will send the signals to 2 and a 3. 2 from the start and a 3 from direction and things like that. And you can see there's another wire that comes past the stop button. This is basically links these 3 up in there, but there's another wire that needs to go back to that number 1. So it's sort of a close that loop off. So it's like a closed loop. So every time that loop is broken, the drive will stop no matter what. So to the stop, goes through. It could have been here, but I just chose to put it down there because it's a nice free spot was down there because these two already were linking up. So that way. So basically, from the 11 goes to normally closed, through to normally closed, goes back to the number 2, links. To number 1. Then it links to normally the start button and directional button, and obviously from start button it goes to number 2, and from directional button it goes to number 3. That is it. Simple. So that way, drive, stop, change direction, start, and stop. That's about it when it comes down to getting your, basically set this thing up with a nice little button station down here. And then there's more connections you can do. Obviously there's other options you can do, because you can sort of reprogram your digital inputs down there. You can set them as for the jog mode. You can put them in a multi-frequency and things like that. I'm not don't think I will do that in the video. I don't think many people use multi-frequencies and things like that. So that is definitely an option you can do. All you need to do is look at the advanced setup. There is all the parameters in there. Which ones you need to do is sort of, it helps you. Let me just. I think there was in one of the manuals part of it was. If you look at the speed reference. Ooh. See, if you look at the speed references, it says number 4 is preset frequencies, and it says external frequency commands as default by A70, A73, when A51 and 52s are programmed as preset frequencies and the digital inputs are active. So you can, using even, it's quite simple, if you select the speed reference, which is parameter 38, you can change that to preset frequencies, and following all the because Allen Bradley was kind enough to explain exactly which parameters you need to change to achieve those preset frequencies. When you have preset frequencies, you can have like a selector switch. You can select speed 1, speed 2, and speed 3, and that way you just have these selected frequencies and nothing else can be changed, because sometimes some specific program setups will require exactly the same frequency at all times rather than changing with the potentiometer. Other than that, This is it. This is as far as I want to explain how Allen Bradley Powerflex 4 works. It's very good drive, very good manufacturer. It comes from one of the leading in the world. These drives are very robust and run very smoothly. We'd be advised to use EMI filters if you can, just to minimize all these magnetic fields and things like that. And then other than that, thank you very much for watching. I hope you enjoyed that. And if you liked it, please click the like. If you don't, then click dislike. And then I will see you next video. Bye bye.